SV Math Teach, back again with quadratic functions, and in this case, transformations. Now I call this transformations, but honestly this is a small little lesson on how to graph using what's called vertex form. Now, the standard form of a quadratic function is this parabola standard form that I have listed here. If I were going to graph using that form, I got to be honest, I'd probably just make a table of values. I'd pick some x's, I'd figure out what my y's would equal, and then I would just make those dots, right? Connect the dots up with a nice smooth curve and you're done. However, there is this alternate technique, which is if you have something given in vertex form, which happens more often than not. If you have something in vertex form, you can pull information right off of the equation itself, like the vertex, and the stretch or compression, and you can graph directly from the equation. So let me show you an example, right? So I have this example up here where you can see what the vertex will be directly from the equation, and the vertical stretch or compression is going to be a lot like slope. If a is greater than 1, you're going to have a steeper line than you might expect, or a steeper curve, I guess. Maybe some people might call it a taller curve. And if a is between 0 and 1, it's going to be flatter. Wider might be another description. If that a value is negative, you're going to find, or opposite, I guess, you're going to find it flipped over and shaped more like an umbrella than a bowl. So let's look at this example that we have right here, and I'll pull off that the vertex, well, I have this list of 5 items, right? So the vertex we can pull off immediately. So the vertex is positive 4 and negative 2. So done. My axis of symmetry has to go through the vertex, so its x is this number, 4. So far I have 2 of the 5 things already filled in. The next is going to be maximum or minimum. Now this number is positive. It's positive 3, but it's positive. That means it's going to look like a bowl. It's going to have a vertex at the bottom and it's going to open up, which means that vertex at the bottom is the minimum. And if I want to identify what the minimum is, I just write the vertex again. If that would have been negative, by the way, it would look like an umbrella. Sometimes a really narrow umbrella, but an umbrella nonetheless, and if it were negative, we would choose maximum because the point or the vertex would be at the very top. Now, the domain is your x value from left to right, and these graphs, because of the nature of a parabola, they're going to open up or down, but out forever. So your domain is going to start at negative infinity, and it's going to go to positive infinity. And there's a variety of ways to show that off, but that would be one way. You could do it with this integral notation, where you do negative infinity to positive infinity, and you do the soft edges, you do the parentheses, because you never actually achieve that infinity. And the range is different, though. The range is going to have to do with the maximum and the vertex, so you need to pull some other information in. Now, I know that my range has a minimum of, and my range is my up and down, so my range's minimum is down here at negative 2, because that's what it tells me my vertex minimum is for the up and down movements. I also know that because I have a minimum, my shape is going to go up from there, right? That's going to be the general shape of my parabola. So I'm going to say it goes from negative 2 up to positive infinity. So I'm going to say something like negative 2 up to infinity. Now negative 2 is the starting point, so I give it a hard edge, but infinity is kind of a softer edge because I never quite achieve infinity. So that's how I take care of those 5 questions. Now as for graphing, very simple. All right, here we go. The vertex was 4, negative 2, so 4, negative 2 looks like right here. And, well, my vertical stretch or compression is a 3. Now what I would have expected would have been a dot here and here, because a normal quadratic function would be 1 over 1 up, right? Because, well, that's from the parent function, y equals x squared. If I put a 1 in, I get a 1 back. So that's the 1 over 1 up, but this one is a times 3 stretch. So I don't go 1 up, I go 3 up, and I get rid of this. You could also do it this way. You could just grab the point and move it 3 times higher than it used to be. Now, my little grid here runs out of space, but when I graph, you're going to see that this is going to be much steeper than it originally was. You also notice that it opens up because this is positive. So that's it. That's how to identify different characteristics of a quadratic formula and how to graph using vertex form.